Merhaba,
Merhaba Mehmet. Nasılsın?
iyiyim. Siz?
İyiyim ya. Bugün nasıl
Hmm,
geçti okul?
iyiydi,
Ne
iyiydi.
zaman eve geldin?
6'da geldim.
6. Çok geç ya.
Evet.
Ne zaman bu saatte mi geliyorsun eve?
Yo, bazen.
Okulda eviniz kaç dakika?
20 dakika.
20 dakika. İyi, çok uzak değilmiş ya.
Evet.
İyi, güzel.
Evet.
Matematik ne işliyorsunuz şeyde, okulda? Bugün mesela hangi konu işlediniz?
Bugün bugün parents function ve parents function ve transformation.
Öyle mi?
Evet.
Bu geçen de işlemiştiniz. Yani parent functions, kaç tane parent functions gördünüz?
Yani sınav olacak da pazartesi de.
Hı hı.
Bir tane practice gibi şey gönderdi.
Bir göstersene bir bakayım. Böyle tut şey, kameraya.
Yani konuları diyor. Relation ve function'lar olacak diyor.
Ha,
Sonra sonra um, linear and relations and function olacak.
hı.
Linear relations and function
Evet.
böyle.
Evet.
Sonra
Bu aslında Mehmet seninle çok işledik de biraz halen kafam karışıyor yani. Linear function demek işte o f of x equals mx plus b var ya.
evet.
O işte yani. İşte
Evet.
slope
Bir
var,
de
y-intercept var, onun grafı var, table var. O kadar başka bir şey yok ki orada.
evet. Bir de special function var.
Ne o? Special function.
Um, şöyle yazıyor. Special
Piecewise defined functions. Ha, tamam. O da çok bahsediyor. Onu da seninle işledik. Hatırlıyor musun?
biraz hatırlıyorum.
Yani aynı şeyde sadece farklı intervalllarda farklı fonksiyon. Ana ayrı ayrı çizmen lazım. Tamam. Başka?
Ve parent function ve transformation o kadar.
Yani o parent function transformation'dan sonra gelecek mi bu senin gireceğin sınavda pazartesi?
Evet, gelecek sınavda.
Hmm, tamam.
Yani ilk önce parent function çalışabiliriz istiyorsanız. Ya da ilk önce
Tamam.
special, ilk önce relation and function mı çalışalım?
Çalışalım da o relation function seninle çok çalıştık. Yani relation demek set of ordered pairs demek. Değil mi?
Evet.
Ondan sonra o işte table var, mapping var. Ondan sonra da equation var.
Evet, o zaman
İşte function demek de işte if every input is paired with exactly one output, it's a function. İşte onu
yeah.
domain bulman lazım, range bulman lazım. Yani
O
çalışırız da fark
zaman
etmez. Benim için bana işte bakalım hangisi en önemlisi oraya bir bakmak lazım.
yo, linear relation'ları bakabilir miyiz? Onları biraz unuttum.
Ya o bilgisayarda var mı acaba sende online nasıl bakacağız? Bende konu vardı, bende soru çok. Ama sende olursa onu
Bakayım.
yaptıktan sonra benimkilere bakarsak daha iyi olur. Benim için fark etmez yani. Sende var mı yani online ya da
Um, bakayım.
ya PDF'de olsa çok güzel olur mesela senin soruların.
Yok. Yok. Yokmuş.
Hı,
Yok. Ben su alacağım da geliyorum.
tamam tamam. Ben de hemen bir ayran alıp geleyim tamam.
Yani
Bir saniye Mehmet, ben de buradayım. Bir şey bakıyorum da. Mehmet, başladık o zaman.
başlayalım.
Tamam. Seninle biraz parents function hakkında konuşalım o zaman, tamam mı? Sonra da domain range hakkında yani konuşuruz da, ama seninle çok konuştuk. Az sonra yine bakabiliriz. Tamam.
Hı hı.
İşte yani aslında çok fazla bir şey yok. Domain dediğin işte orada the set of input values, right? X values. Range is the set of Y values. İşte onu üç çeşit şeyde yazabilmen lazım. Interval notation, set builder notation, or just as inequality. Tamam. İşte
Hı
onu
hı.
oturuyor iki üç tane sonra sen kendin çözersen hepsini anlarsın. Çünkü hepsi aynı şeyler, farklı bir şeyler değil. Yani. Anlamazsan 50 tane soru çözse yine anlamazsın. Yani. İşte onu
Evet.
onu temelini anlayabilmen lazım. Onun için de oturup iki üç tane soru kendin çözmen lazım. Ne oluyor, ne bitiyor, neden böyle oturup böyle.
Evet.
Tamam, başladık hadi. Oku şeyi, parent function ne demek? Parent demek zaten anne ya da baba demek ya.
Hı hı.
Yani bir tane fonksiyon var, ondan başka fonksiyon türüyor, tamam mı? Ona da parent function diyoruz yani. Tabii okusana, function demek ne demek, yani parent function ne demek?
A function family is a group of functions with similar characteristics. The parent function is the simplest of the functions in a family. You must be able to recognize each of these functions along with their characteristic.
Yani burada böyle çok fazla fonksiyonlar yok Mehmet. Sen şimdi kaç yaşındasın? 14-15 yaşında. Belki
Anladım.
25-30 yaşına kadar hep bu fonksiyonu göreceksin. Kaç tane fonksiyon var? Belki 12 çeşit, 14 çeşit fonksiyon var. Tamam mı?
Evet.
Bunları iyi bilmen lazım yani. Şimdi hemen anlayamazsın da, ama zaman geçe yavaş yavaş yavaş yavaş kafana oturması lazım yani. Böyle hep böyle sürekli kullanılan fonksiyonlar. İlk başta şundan başlayalım yani. Mesela parent function. Hangi fonksiyon bu, hatırlıyor musun?
X, y equals x.
Hı?
Y equals x. Ha
Y
şey.
equals x.
Evet. Y equals x.
Değil mi?
Evet.
Kırmızı ile yazayım, belki daha iyi gözükür. Biraz büyütelim. Evet. Tamam, işte bunu hatırlıyorsun. Yani şimdi mx plus b var ya, the general form.
Hı hı.
But that's the simplest form. The simplest form is f of x is equal to x. Yani o mx plus b'ler var ya, işte o fonksiyonun babası ya bu fonksiyondur yani.
Evet.
İşte bunu sola, sağa, yukarıya, aşağı çekerek ya da böyle we call this horizontal compression, horizontal stretch. Yani
Hı
bir
hı.
transformation yaparak başka fonksiyonu elde ediyoruz yani. Genel olarak şekli değişmiyor yani. İşte o
Evet.
yüzden diyoruz yani the parent function is the simplest form of the functions in a family. Yani bunun family'si nedir? Mx plus b yani.
Hı hı.
So what is the domain of this function?
The domain is all real numbers.
All real numbers, as you see here, because if you just put your pencil and if you scan this from left to right, right, you're scanning the whole graph, right?
Yeah.
Every point I can touch the graph. That's why it's all real numbers. How about the range?
The range is 0.
No, range y values. Put your pencil from this lowest point, and if you just move the scan this from the bottom to the top, right? You're scanning the whole graph, right?
Oh yes, real
You
numbers.
see, if I draw the front end here, I cross the axis, right? The graph,
Yeah.
right? At any point, right? So
Mm-hmm.
that means that the range is all real numbers.
Yeah.
Tamam mı? Şimdi böyle sıfır desen hemen bana kafam şey giriyor. Herhalde sen ilk defa görüyorsun bunu. Öyle dememen lazım. Çünkü y values ya bunun kaç tane y value'su var? Infinitely many.
Evet.
Değil mi? X intercepts
0.
0 0.
Yeah.
Y intercept
0 0.
0 0. Extrema
Um.
extrema biliyorsun değil mi? Local
Like
maximum, local
negative
minimum.
infinity.
Global maximum, global minimum.
Uh. Extrema 0.
Bir saniye Mehmet, hemen burada bir tane şey açayım da bana not için kağıt lazım. Yani ekstreme demek Mehmet. Şunu şöyle bir graf çizsem, şu bizim y-axis, tamam mı? Bu da x-axis olsun. Tamam mı?
Hı-hı.
Şimdi böyle bir graf çizeyim sana. Şöyle bir şey olsun, tamam mı?
Maximum ve minimum.
Evet. Extreme
Ha.
demek extreme points demek yani. Extreme demek ne demek? Ya çok yüksekte ya da çok şeyde
Evet.
düşükte. İşte bunlar extreme points ya. Local maximum, local minimum, local maximum, local minimum.
Evet.
If actually
Ama
it goes to infinity, it doesn't have global maximum. If it goes down, right, infinite, it doesn't have what is it?
minimum.
Global minimum or absolute maximum. But in this question, this one, does it have any local maximum or
No.
local minimum or maximum minimum?
No.
No. So it is none. It doesn't have any extreme points, right?
Mm-hmm.
And increasing intervals.
Starts from 0.
No, everywhere it is increasing, right? If you move from left to right, every time the function is going up, right?
Yeah.
So the increasing intervals from negative infinity to positive infinity. Yani increasing demek Mehmet soldan sağa böyle yürüdüğün zaman if you walk on the x-axis from left to right, look at the graph. Is it going up or down? See here, if I just move in this direction, right, every time the function is going up, right, you see?
Evet.
Everywhere is increasing. That's why over the whole entire real number line, the function is increasing.
Evet.
And decreasing?
Um. Infinity to negative
Do you
infinity.
have any interval over that interval? The function is going down.
No.
No, so there's none.
Oh
We
yes.
don't have
No.
any interval that our function decreases, right? When you walk from left to right, it goes down. We don't have any such interval, right? That's why
Mm-hmm.
it's none. And how about end behavior?
None.
What do you mean none?
Like it
End
continues.
behavior means that its domain is R, right? R
Yeah.
means that, what does R mean? It means that from negative infinity to positive infinity.
Yeah.
Endpoints are negative infinity and infinity. And end behavior means that what happens to the value of the function when x approaches positive infinity or when x approaches negative infinity. End behavior means this. Ya
Mm.
domainin son noktalar var ya,
Evet.
soldaki en son nokta, sağdaki en son nokta. Şu onlara yaklaşırsan fonksiyonun değeri ne olur? Çok mu büyüyecek ya da çok mu küçülecek? Yoksa
Büyüyecek.
herhangi bir sayıya mı yaklaşacak? O demek ya.
Evet.
O zaman nasıl yazıyoruz bunu? Bu mathematical şeyde yazman lazım yani onu. Çünkü bu is a kind of first step to understand limit concepts. So what do you write here? As x approaches positive infinity, let's start with negative infinity, right? And so here, if you move to the left, the function is going down. So f of x approaches negative infinity, right?
Evet.
And the second one is as x approaches positive infinity, f of x
If
approaches what?
x goes positive.
Positive infinity.
Yeah.
Now discontinue this.
No,
Bu
it's
discontinuity hakkında
continuous.
şey öğrendiniz mi?
Efendim?
Bu discontinuity.
Yo.
Öyle mi? Tamam, o zaman bunu şey yapıyorum, atlıyorum. Tamam. Devam ediyoruz. İşte bu kadar yani. Normalde bunları sorar. Başka bir şey yok yani parent function hakkında.
Hı hı.
İşte bunu özellikle bilmen lazım yani. It's how to find a domain and range, x-intercepts and y-intercepts. These are the characteristics of a function. Tamam,
Evet.
şimdi bunu hatırlıyor musun Mehmet?
Hı hı. Evet.
What function is it?
So domain,
No, what is the parent function?
oh, it's absolute value.
Very good. So that's very good. That is absolute value function.
Yeah.
Domain,
Domain is starts from 0
no,
to,
how come zero? Look at the graph. If I go from here, go up, I can meet the graph. From here, go up, I can meet the graph, right? I can see the meet the graph, right?
yeah.
So that means that everywhere, the entire real number.
Oh
Why
yeah.
I say from zero on the left hand side, also we have the part of the graph, right?
Mm-hmm.
Any point, right? Can I actually meet the graph if I go up? Yes. That means that every point is the domain point.
Yeah.
And how about the range?
The range, um, so it touch, I mean, goes to, yeah, all real numbers.
No, Mehmet, no. I think still you don't understand what is domain, what is range. Y values, look at the graph. Do I have any, for example, for what value of x, the function's value is -2, for example? Nothing. Under the, below the x-axis, we don't have any graph, right?
Yeah.
The whole graph is above the x-axis, right?
Mm-hmm.
Right? It is here, it is
Oh,
here, it is here, but below the x-axis, we don't have any part of the graph.
yeah.
So domain is y is greater than or equal to 0.
Oh,
Because you know the absolute value is always greater than or equal to 0, right? It's
yeah.
never negative,
Mm-hmm.
right?
Yeah.
Okay, how about x-intercepts?
0, 0.
0, 0. It has only one x-intercept, right? At 0, 0, it actually here, it touches the x-axis. Y-intercept?
0, 0.
0, 0. Okay. Extremum?
No.
There is. Look, here we have a turning point. It says minimum value, right? Look at the range. Y is greater than or equal to 0. What does it mean?
Oh, it's 0.
So that is absolute minimum
Yeah.
at
0.
0, 0.
Yeah.
At this point, the function has absolute minimum. That's the smallest value of the function.
Mm-hmm.
Okay,
Increasing.
how about increasing intervals?
Yeah.
What is it?
Oh, infinity to infinity?
What?
Oh no, 0 to infinity.
0 to infinity. From 0 to infinity, the function going up, right?
Yeah.
The increasing interval from 0 to infinity. And how about decreasing interval?
No.
Come on, Mehmet. Come on, Mehmet. Look at the graph.
Oh no, 0. I think it's 0 to.
Mehmet, I don't know how can I explain this. I'm saying that when you go from left to right, if the function's graph is going down, that means that over that interval, the function is decreasing. Look at the graph. For example, from here, right? -5, -4, -3, -2, -1. Look at the graph. It's going down, right?
Oh.
If you go from, for example, -5, -4, -3, -2, the function is going down, down, down, right? Until this point, right?
Oh, left side is like decreasing.
Yeah, of course. Look at the
Oh,
graph.
okay.
If you go from left to right, look at the graph. It's going down or up?
Yeah. It's
Going
going.
down, right?
Yeah, down. Okay.
Okay. And behavior. What happens
Uh,
as x
as x,
approaches -infinity?
fx goes negative infinity.
Really?
Oh no, infinity.
It's going to up, right? So it is positive infinity. And how about as x goes to or approaches positive infinity?
If x goes positive.
That's right. Okay. Next function. You remember this function?
I think it was
What is the name of this graph?
what was it?
Parabola.
Logarithm? Oh no.
Parabola.
Oh.
It's a quadratic function. F of x is equal to x squared.
Oh yeah.
Did you study about quadratic functions? I mean, just the graph.
Like what do you mean?
Hmm?
What do you mean? Oh, like we kind of studied, yeah.
It's at school. Did you actually see this kind of graph or not?
Yeah, we did.
Okay. Now, what is the domain?
Domain, are real numbers?
Yeah, all real numbers. You see, I can actually put anything here. If you give me any number, I can square this, right? And that's why domain is all real numbers. How about the range?
So the range, how do you do the range? Like
Put your pencil horizontally. If I
like
just put this, the first time I touch here, right?
yeah.
So that is the smallest value here, right?
Oh yeah, 0.
All values are above this number. That's why in set builder notation, how do you write this?
0
This one
to
is such axis where, sorry,
oh
this range, right? It's y. Y, where y is greater than or equal to 0. In case
oh
actually if your teacher asks you to write in set builder notation.
yeah.
X-intercept, Mehmet?
0 0
0 0. And y-intercept?
0 0.
0 0. Does it have any extrema?
Um yeah,
What is it?
0 0.
Yeah, at 0 0, it has, we just write here, absolute, minimum,
0. Oh yeah.
at 0 0.
Mm-hmm.
Okay, that means that at this point, the function has minimum value.
Mm-hmm.
Increase the interval,
0 to infinity.
0 to infinity. And decrease the interval.
Negative infinity to 0.
Very good. And behavior,
No.
what do you mean no?
Oh wait, 0.
As x, always they have, as x approaches positive infinity, you forget so quickly again. And behavior means that the end of the domain. Since the domain is real, all real numbers, that means that it goes to positive infinity, negative infinity. So now you have to say that what happens to the function when x goes to positive infinity or negative infinity. So when x approaches positive infinity, f function approaches what?
Infinity.
Positive infinity. And how about as x approaches negative infinity?
Negative infinity, it goes positive.
You're positive because it's going up right every time.
Yeah.
And how about x cube function? Mehmet, did you study also about this cubic function?
Yeah, cubic.
And what is the parent function?
Y equals x cube.
Very good. So y or f of x, we can write y or f of y, it doesn't matter. X cube.
Mm-hmm.
What is the domain?
All real numbers.
All real numbers. Range,
Range,
look at the graph.
mm, it goes to negative and infinity.
Range, what is the range of this cubic function?
All real numbers.
All real numbers. You see, actually the graph is going down, right? It never stops. This arrow means that It just keeps going down.
Yeah.
And the upper part also arrow. That means it just keeps going up, right? So that's why the range is all real numbers. X-intercepts?
X-intercept 0.
It is 0, 0. The origin, right? And Y-intercept?
0, 0.
It is 0, 0. And extrema, does it have an extrema?
Yeah.
Where?
Oh, no, 0. Yeah, 0, 0.
Huh?
It says 0.
What do you mean 0?
Wait, extrema was maximum and
Do we have this kind of point, turning point,
oh no.
like this, or like this, or like
Oh,
this? Or maybe I can just add something, maybe it's a turning point, something like this, or something like this.
no.
It doesn't have. You see the extrema means that where comparing to some other points, the function has a maximum value or minimum value. To understand this,
Yeah.
just imagine the mountains. Okay, mountains, the higher points and lower points. By
Yeah.
higher points or lower point, we call them extremum points or simply extrema.
Mm-hmm.
So we
So
call this
it's no.
extreme values, right?
Yeah.
So it doesn't have any extreme values here. See, it doesn't have any turning points. It is not. And how
Mm-hmm.
about the increasing intervals? Where does the
0,
function increase here? Huh?
0 to infinity.
Really?
Um.
Can you look at the graph carefully and
Mm, uh.
what does increasing mean, Mehmet?
Up. It goes up.
When you move from left to right, the graph of the function goes up, right? Rises.
Yeah.
So now look at the graph. What is the increasing interval for this function? Over what interval the function increases?
Um.
Mehmet. It is all real numbers.
Oh
You see all the time the function is going up, right? Going up. We have any interval that function is going down?
no.
When you move from left to right? No.
Oh.
Okay. And how about the decreasing intervals?
Our numbers
Really? Show me where the function decreases here.
at the bottom.
Really? Now, if it means that, like, for example, I'm at -2, it is somewhere here, right? And -1, the function is going down.
No, it rises.
In decreasing means that, Mehmet, look, here, if you look at the graph, okay? So at this point, right? At this point, it is this, right? And let's say this 3. So I'm moving from left to right. Next point, let's say this point is 4. And the next point of the graph is here, right?
Mm-hmm.
From point A to point B, the function actually, it goes down or up?
It goes up.
Down. How come up? You look at this A, now it's going down, right? From A, now it is here B,
Oh,
right?
yeah.
So that means that here, the function is decreasing. You see, it's going down. As you move from left to right, I was at 3, it is equal to A. I have 4 is equal to B. If I move again, let's say this 1 point is going down, right? So in this interval, the function is going down. So that means it's decreasing.
Yeah.
And how about here, for example, let's say at this point, the function value is this. At this point, the function value is this. At
It
this
goes
point, the
up.
function value is this. You see, every time if I keep moving to the right, the functions graph, points are going up, right?
Yeah.
So that means that over this interval, the function is increasing, is going up when you walk from left to right. Simply, actually, increasing means that here, if we are given some function here, let's say this one is A, right? And this one is B. When you move from A to B, right, the function's value is going up. You see, it's going up like this.
Yeah.
Yeah, you are saying yeah, but still you get confused, Mehmet. And here, this one is decreasing. So this point is, let's see here, this point is A, and this point is B, right? The function value, let's see, is decreasing here, going down.
Mm-hmm.
The
Oh,
simple if you move from left to right, if the function going up, the graph, so that means that it's increasing there. When you go from left to right, if the function graph is going down, that means it's going down.
okay.
You say here in every case, you know, if I just join, for example, one point is here, another point is here, right? I'm moving to the right, and here, and here, and here, and here. Every time it's going up, right?
Mm-hmm.
So that means it's increasing. And how about decreasing interval? It is none. It's always increasing function.
Yeah.
And how about end behavior? End behavior means that as x approaches positive infinity, let's say with negative infinity, a function approaches what?
Positive.
Negative infinity is going down.
Oh, yeah.
X as x approaches positive infinity, this function goes up,
Positive.
right? Positive infinity.
Yeah.
Okay. And now to understand this, Mehmet, you know, you can just draw this in Desmos and see the graph, what happens when you move from left to right, okay?
Mm-hmm.
All right. How about this function? Do you remember this?
It was, I know it was y equals 1/2.
No,
No, x over something.
no. Square root of
Oh,
x.
square root function. Yeah.
Because square root of x, Mehmet, we know that under the square root, we cannot write negative number, right?
Mm-hmm.
So that's why when x equals, x is less than 0, this function is not defined.
Yeah.
Because under the square root, we cannot write x. So we call this a square root function. We have square root
Mm-hmm.
functions. All of the square root function parent is square root of x.
Mm.
You understand
Yeah.
what? Like, for example, let's say now square root of x, right? Equals square root of x. It is this function, you see? And now
Mm.
what happens if I add something, if I subtract something? In general, the shape does not change, but maybe you just squeeze this or stretch this, move this to the left. I want to move this graph to the left, for example. Let's say 3 units. What do I do here? And just add 2, for example. Let's say 2. You see the function move 2 units to the left.
Mm-hmm.
And I want to move this up, for example. Let's say the original function, right? I want to move this up 2 units. So again, I need to add 2 to the whole function. You see now it's shifted 2 units up.
Yeah.
Now I want to compress this, for example, this function, okay? Compress it horizontally. So that means that I need to multiply by some less than, what is it? One number. You see here, less than 1. Now it's a bit fatter now. Maybe you cannot see this, but actually guess, what is it? We are just
Deeper.
stretching this horizontally. And how about
Oh,
if you compress it horizontally? Let me multiply this by, let's say, 4. Right?
yeah.
Okay, that's all of these functions. Okay, it can actually they are from this parent function, square root of x. Anyway, what is the domain of this function, Mehmet?
Domain is it goes from infinity
Such x's
x
where
bigger x bigger than equal to greater than equal to 0.
0.
Yeah.
That's right, because when it is negative, it's not defined. How about
Yeah.
range?
Range is uh so if it's horizontal, like it does not touch anything.
Y values. Look at the y values. What is the minimum value of y?
0.
0, right? All of the actual graph is above the x-axis, right? It's
So
just going
0,
up.
0
So
bigger than equal
y
to 0?
greater than or equal to 0.
Yeah.
And x-intercepts
0.
0, 0, right? At origin. And y-intercepts
0.
0. Does it have any extrema?
No.
Yes. It
Oh,
has a
yeah.
minimum value here, right? 0, 0. That's the minimum value of the function, right?
Yeah.
So it has absolute. At school, did you learn as absolute or global?
Absolute, I think. Yeah.
Okay. Actually, absolute minimum or global minimum, absolute maximum, global maximum, the same thing. Local minimum or relative minimum, okay, local maximum, relative maximum, they mean the
Oh,
same
yeah.
thing,
Local. Local.
right? Local, absolute, the same, local or relative, doesn't matter.
Yeah.
Anyway, from book. So that it has absolute minimum at 0, 0.
Mm-hmm.
And how about the increasing intervals?
0 to infinity.
Every time it's going up, right? The function. That's why over this interval, the function is increasing. Decreasing interval?
None.
None, because it never goes down, right? All the when you walk from left to right, it's going up. And
Mm-hmm.
behavior?
No.
What do you mean no, Mehmet?
Oh,
And
0,
behavior
0.
means that what happens to the function?
Oh, yeah. As x goes to infinity.
No, here the smallest value is 0, right? It doesn't go to negative infinity. Let's start with left-hand side. As x approaches 0, right?
Mm-hmm.
The function approaches what?
Infinity.
0. What do you mean?
Oh,
Look, if you just get closer and closer to 0, when it is 4, it is 2. When it is 2, square root of 2. When it is 1, it is 1. What is 0 0.1? As I get closer and closer to 0, as the function is getting closer to 0, right?
yeah.
So f of x approaches 0. And as x approaches positive infinity, f of x approaches what?
Positive infinity.
Positive infinity.
Yeah.
Okay. How about this function? Cube roots.
Cube root is like y equals x square, cube root, cubic root.
Cube root of x, right?
Yeah.
So again, Mehmet, I suggest, every time if you cannot visualize, draw this. Then you can see that. So that is, what is it? How to write
3
cube roots?
cubic.
You say I cannot write this one. So I just write it as x to the power of 1 over 3.
Mm.
Okay. Now see here, when you just walk to the left, it's going to the left, right?
Mm-hmm.
And go to the right, it's also going to the right. Okay. So domain, what is the domain of this function?
All real numbers.
All real numbers. Because as you see here, x, it goes to positive, negative infinity, and also on the right-hand side, it goes to positive infinity. How about range?
Range is all real numbers.
All real numbers. You see this arrow, it keeps going down, right?
Mm-hmm.
And also arrow on the right-hand side, it just keeps going up. Maybe slowly, but still it goes up. It keeps increasing.
Yeah.
Like cube root of 1 million and cube root of 1 billion, right? Each time, actually, as if x is greater, also the value of the function is getting greater, right?
Mm-hmm.
So that means that as x approaches positive infinity, also the value of the function approaches positive infinity.
Yeah.
And how about the x-intercept?
0, 0.
0, 0. Y-intercept?
0, 0.
0, 0. And extrema, does it have any extreme points?
No, 0, 0.
No, there's no any turning point, right? It is just none. And increasing intervals?
0 to infinity.
No. Look at the
Um,
graph carefully, man. It's
oh
always
no,
going up, right?
negative infinity to infinity.
Yeah, you see, it's always going up. We don't have any interval that function goes down. So that's why it is from negative infinity to positive infinity. Decreasing intervals?
No.
None. Okay. And behavior?
Um,
Mehmet, you need to write it down. Otherwise, you don't understand
Oh
this.
yeah,
Maybe
as
if you write
x
1 or 2 times as
x goes
x
goes to
approaches negative
to
infinity,
fx goes to positive.
f of x approaches negative infinity, right?
Oh, negative, yeah.
It's going down, right? See, that is minus infinity. As
X goes to positive.
x approaches positive infinity, f of x approaches
Positive.
positive infinity.
Mhm.
Okay. How about this function?
Wait, what's this continuous? Like,
Discontinuity means that the function is disconnected somewhere.
oh, so this is continuous.
No, this one is continuous, yes. And also this one continues everywhere. And also this one continues. Also this one continues. Actually,
Oh,
continuous means that Mehmet, can you draw the graph of the function on the paper without lifting your pencil off the paper?
hmm.
If you can do this, continuous. If you cannot, it
Like,
is discontinuous.
like this is this continuous?
Let me see. Uh, wait. Okay. It is not continuous. See, at 2, right? It's not connected.
Yeah,
So that means that at 2, at x equals 2, the function is not continuous. That means it's discontinuous.
yeah, we
And this
learned that
kind of
too.
continuity is called jump discontinuity because at this point you're jumping down, right?
Mm-hmm.
You cannot connect this
Yeah.
because usually now at this age, Mehmet, you're going to study 3 types of discontinuity. One is jump discontinuity. That means, as you see in the paper, is jumping. The second
Oh.
one is removable discontinuity.
Mm-hmm.
So that means that just only one point is missing from the graph. It's like,
Mm-hmm.
for example, if you draw this, okay, I have the graph, only one point is missing. Again, it continues.
Oh,
One point is missing here.
okay.
And the
Yeah.
one you show me, there's something like this, right? Here, maybe it's defined here or not defined, I don't know.
Yeah.
And from here, let's say it continues here. Okay, maybe this kind of function. Let's jump
Mm-hmm.
discontinue. And another one is sometimes we have this kind of graph, okay, but they never meet each other. So we call this infinite discontinuity because
Mm.
they go to infinity, but they never meet each other. It's like, for example, if you look at this function, okay, its function equation is 1 over x.
Yeah.
You see here at 0, is it defined? No, because I cannot divide 1 by 0, right? But
Mm-hmm.
if you look at the graph, right, if you approach 0 from right hand side, it's going to positive infinity. If
Yeah.
you approach 0 from left hand side, it's going down, right?
Mm-hmm.
So that means that it has kind of discontinuity at 0. And what kind of discontinuity is it? It is infinite discontinuity.
Yeah.
So what is the domain of this function?
Domain is it goes from, oh no, it's
It's 10 builder notation. We can write like this, Mehmet. Also, you need to practice. Very nice, beautiful things, but at the first time, students get confused. Once you understand, it's just a very practical way of writing things. So that
mm-hmm.
means the domain is any real number, only x is not equal to 0.
Yeah.
Because x is not equal to 0, right? We cannot divide 1 by 0.
Mm-hmm.
Okay. And how about the range?
The range is y y equals uh 0. I
Any
mean,
number not
how do
equal
you
to
say that?
0.
Yeah, how do you say the equal term?
Yeah, not equal. It means it
Oh,
is a set of real numbers where y is not equal to 0.
yeah.
Because here at 0, we don't have any graph, right? Any part of the graph.
Mm-hmm.
And x-intercepts?
None.
None. Y-intercepts?
None.
None. And extrema?
None.
None. And increasing intervals?
Yeah.
No, no, no. Mehmetciğim ya nasıl anlamazsın ya? Just it's going down, right? Do we have any parts going up when you walk from left to right?
Oh yeah, no,
It's
no.
always going down. You see, if you look, put your pencil and draw this, always going down, right?
Yeah, but
When
what
you move
about the
from
right
left to
side?
right. Also here, when you move from left to right, always going down, right?
Yeah,
And that means that it's never increasing. We don't have any increasing intervals. So increasing intervals, it is none.
yeah,
And how about in decreasing intervals?
yeah.
Decreasing intervals is from negative infinity to zero and from zero to positive
Infinity.
infinity.
Yeah.
You have to show like this because at zero it's not defined, right?
Uh-huh.
And how about n behavior as
Mm.
x
Oh yeah,
approaches
as x
negative
goes,
infinity,
fx goes negative infinity.
negative infinity, right? No, no, no, no, no, no. I'm confused here. What happens to the function as x goes to negative infinity? Look at the graph.
Mm-hmm.
Huh? It's approaching what?
It goes down, negative.
No, negative infinite. Look, it's negative infinite this way, right?
Yeah.
So it's approaching zero.
Oh, yeah.
And how about as x approaches positive infinity, f of x approaches
Zero.
zero again. You see, it's getting closer and closer to zero, right?
Yeah.
And this continuity, actually, you can say yes at
It's infinity.
zero.
Oh,
Okay. All right. How about exponential function? Did you see that?
what's that?
If you didn't study, we don't have to see this, but if you studied, then we can have a look.
Like, what's the formula?
The formula is here y is equal to a to the power of x.
Oh yeah, we saw that.
And here, let's say a is greater than 1.
Oh, I don't think we
Did,
saw that.
did you see this?
No.
Okay, like 2 to the power of x or 3 to the power of x or 5 to the power of x, they're called exponential function. What is it? Exponential functions. No, this is exponential function, right? No, no, no. That's not a to the power of x. What is exponential function? We mean e to the power of x.
Oh no, not E. Oh, well, I don't know.
Okay.
Yeah, we did not see this.
But actually, when it is x1, it is 2. But in this case, actually, this function it is 2 to the power of x. Because of this graph, it's 2 to the power of x.
Oh, yeah.
If you didn't study, I think maybe you saw actually studied about these basic ones.
Mm-hmm.
Linear function, an absolute value function, and quadratic function, that's parabola, and cubic function,
Yeah, we
and
saw that.
square root function, and cube root function, and the reciprocal function.
We also saw a logarithm
Really?
yeah,
So this one is because if you saw logarithm, also you must have seen this exponential function.
yeah, probably.
Because before logarithm, first you have to study exponential function. From exponential function, then we actually, get logarithmic functions.
Mm-hmm.
They are
Yeah,
related to each other.
we probably saw this. Yeah,
Okay. Now this one is logarithmic function. You see?
it's x equals log x or something
Yes.
formula. Yeah,
It's like logarithmic means that f of x is equal to logarithm of x.
hı. Hocam dersimizi 2 dakika bitirebilir miyiz?
Tamam bitirelim Mehmet.
Tamam.
Mehmet şimdi pazar günü akşam dedin. Yarın nasıl? Görüşüyor muyuz yarın?
Yarın evet görüşürüz.
Onda değil mi?
Hı hı. Çünkü
Tamam
abi
onda.
programı var da
Ha?
yarın. Abi programı var yarın.
Kaçta?
6'ya yani sleepover
Ha, tamam
yatılı
yani
kalacak.
sen Bizim zaten gündüz saat, yani saat 10'da ne yapacağız?
Saat 10'da
Bir worksheet'lerin var mı? Yani worksheet varsa onu yapalım. Olmazsa ben bunları bir bakacağız yani işte domain'dir, range'dir, increasing interval'dır, decreasing interval'dır. Bir sürü şey var bende. Bende çok şey vardı işte sende olursa senin şey kağıdına baksa daha iyi olur. Olmazsa benim elimdeki şeylere
yani
bakacağız.
evet bu olabilir. Sizin kağıdınız.
Evet.
Worksheet
Tamam. Sen
olur.
yine de elinde bir şey varsa bir gönder bakalım hangi konudan soracak. Ama genel
Fotoğraf
olarak
çekerim.
aynı şeyler. Fonksiyon dediğimiz zaman ilk başta mesela verilen bir relation fonksiyon mudur değil mi de onu bir bakman lazım.
Evet.
Sonra da
Fotoğraf
işte
çekerim yani.
domain, range. Tamam. O zaman yarın görüşelim. O zaman yarın devam edeceğiz. Tamam.
Tamam.
Yarın
Tamamdır.
10'da. Tamam. Yarın
Siz
görüşmek
kültür
üzere.
merkezi gidecek misiniz ya?
Ha?
Kandil mi bir şey mi? Yarın
Evet
kültür merkezi.
akşam gideceğim.
Ha, tamam. Ben de.
İnşallah. Ya gitmeyi düşünüyorum yani. Benim çocukta program var. Onu bırakıp böyle gitmeyi düşünüyorum.
Hı hı.
Tamam.
Tamamdır.
Belki şey gelirsen orada görüşürüz.
Evet.
Pazar
Tamamdır.
günü işte yarın konuşuruz tamam.
Tamam.
Tamam,
Görüşürüz.
yarın görüşmek üzere.
Bay bay.